Okay, so we quickly import that file. So that file basically it is an ANSYS file. Okay. ANSYS more specific, actually, it is a space clamp, because space clamp is the part of the model or modular inside the ANSYS. So now I already import it. So now we can do the rigid dynamic simulation for today. To be safe, every time you import an assembly, okay, assuming that you all have CAD background, so I use the word part assembly, you know what does that mean. So you import an assembly, always good is you check, are they completely import? Sometimes happen. Some of the assembly part, they are missing during the import. Okay, maybe it's student license, they have limited something. Or sometimes it be just a translation. Okay, you're using SolidWorks, you translate maybe to the set file or IGS or step file. Okay, they might having some missing. There's always have a tendency happen. So always good you check. Okay, on it. Okay, they're all there. So here I don't want to play with the engineering data, so I will use the default material that is the structural steel. Okay. Okay, so I proceed. So everybody's okay. So when the time we import assembly, this is applicable to the static structural also. When the time you import assembly, the very tedious thing is your connection. By default, they were able to detect the contact between the part and the part, the face touching. So they will automatically detect the contact. Okay, and contact, I'm not very sure you're familiar with it, but I'll give you a general explanation. You've got to choose very careful. And here the contact, basically you will have a few options here. Okay, general, bond, no separation, frictional and rough. Force frictional, it will happen here, but they may not happen in transient or explicit. Okay, so but general actually we're having some of this. Okay, give a quick explanation. Bond is mean that you can assume the two parts is welded together, they stick together. Okay, no separation is mean that they will be sliding towards one another, but they did not separate. Okay, that face they will stick to one another, but they will be having like friction. Okay, they are like sliding. Okay, yeah. Even though here say no sliding, but they are functioning. If you look at that, there's something like that. Frictional is also sliding, but you did not apply any friction coefficient, so they are like a very smooth surface sticking. Here don't have frictional, that is on the transient, but frictional is saying that the two contact in the initial starting, they can in a situation not touching. Then later you can touch. Remember that we set up step, right? First step, they may not touching, but second step, they can touch. Then we use frictional. Okay. Rough is actually like frictional, but they are very rough. Okay, that's sliding. Okay, force friction. So that is what actually we are having. Okay, there's saying that frictional force, that force actually able to drive something. Okay. But normally when the time we set up this, unless you are very sure what you want, my practice is I will suppress all this in the beginning. Okay, in the beginning, especially for rigid dynamic or other dynamic simulation, as long as you want some movement and motion. Because when the time you want some movement or motion, normally the contact region, either you got to be very specific to it, or actually it doesn't need that at all. So you not need no need contact. Basically, it is the join over here helping us to define our assembly movement or the mechanism of our assembly. Okay, using the join. Okay, now we try to take a look at our assembly here. If you want to study well on your assembly, because now you look at it, you feel that very difficult if you want to know internally. You can go to display and then the explore here, you can play with this. Okay, you can play with this. This is just helping you to see internally, but they are not really exploding. Okay, they are just for display purpose only. Okay, SolidWorks, you explore it. Okay, then you have a few configuration you can do. But here, this one is just for view. Of course, you can do something on that, but generally, this is what for us. So that we can click surface easily. Okay, so now I just try to explore a little bit and to explain. So universal join, you can see that the bracket. So click on that. So we are going to rotate on this direction. That it is about the z-axis rotation. And this green color, they're attached to here. So we will have the y-axis rotation. And this cylinder here, so they will give us a translation. That means they can go in and out, okay, on the cylinder. So basically, our assembly, we are having movement in this manner. Okay, so now I just draw them back. And back to the connection here. So now I would like to set up the join, okay, to define how it is. If you don't set up the join, even though now they are like assembled together, but in ANSYS, they will be taking like actually they are no relation at all towards one another. It's just looking they are joining together, but as assembly started, when simulation started, they will all depart. Okay, they will all depart and then they will just go into pieces their own way, because we did not define their relation. We did not define their join. Okay, this is simulation. Starting, we call all this is black box. Okay. Okay. Now, I want to define so-called the cylinder with this holder first. Okay. My cylinder with this holder and body to body. That means I want to define two body, their relation. Okay. Hey, hold on. Okay. So if it doesn't happen, then just click on the connection here. Just now you're all see them. Okay. Here, one of the disadvantages is they are having all these very general term, but they did not have a picture actually to show you what does that mean. So you have to be familiar with it. So I just introduced some very common. Cylinder is like what we are having here. So the cylinder insert into a hole, and then they can in out actually from the mechanical hole. Okay, revolve it is like rotation. So a ring and a cylinder, then they can rotate. This translation basically is just talking about the linear movement. Okay, so this tree might be very common for us. Other you can try, okay, on that. But here I just explain this tree very common we are going to use. So in our case here for this cylinder and this holder, we are going to use cylindrical. So on the cylindrical here, we need to select their face. So if you look at the detail on the left hand side here, okay, the detail on the left hand side here, so you will be seeing that you need to select two. Now there's no selection. One they call as a reference, another one they call as a mobile. And the view is here. So now I will select this face. Okay, if you want to have a selection filter, you can use this. Okay, I select this face. And then I will be using the reference scope, click apply. So now they'll be there. So this one is rotatable. So saying that now I selected one face, and this face we are going to have a cylindrical relation with the holder. But I can't really select the holder inside, because now you can see that I'm not able to select that. okay, very effectively. I know you can use select all, or sorry, select others, or select all here to give you the view. But here actually, the latest version, last time the version, that's the only method, but now they are quite convenient. I can select this part first, okay? I can select this part first, let it appear here. I know that this surface of the blue color is not the one actually I want to select. What I want actually is internally. But I can select it first so that it can appear in my mobile here, mobile body view here. Then now I select that face and click again. So now I successfully established the relation, okay, for these two parts. Okay, so easy. Last time we need to use select all and then the face that touching on your mouse, then you select step layer by layer. If you first time using ANSYS, you may not know. If you're using old version, then you maybe understand what I'm talking about here. Okay, so now I have established that. And if you don't know what is cylindrical, after you establish, you can try to study it. Okay, you can try to study it by clicking the configure. Okay, so now I already established it. So I click configure. So you'll be seeing that. Okay, so now it's saying that those that are selectable, okay, highlighted. That means that it is the movement it allows. They allow it to rotate, definitely. Now you see the holder follow to rotate because the holder, it doesn't have any relation yet with other part. So that's why you follow the cylinder to rotate. Later we will establish that, then it will not follow. But this is to show us that, okay, they can rotate. Okay, and after that, you can click one more time and test on this. So it can basically having this translation also. You can just depart them, no problem, because once you close the configure, they will back to original. Okay. So by that, you can basically study what it is, the other join, how they define between part and part. Okay, so that's how it is. There's other so-called function over here, but I don't want to complicate it, the whole situation first. Maybe in the future we can talk about it. But all this is just to ease your design only. Okay, nothing to do with your analysis. If you still prefer doing your design work at SolidWorks or, then no issue. And normally, the practice in the industry is I may use SolidWorks to design. But when I want to change the design, I want to fine-tune it based on the simulation. Then normally I will use an internal 3D modular of the simulation software. And here is base clamp. Okay, so now this is done. You can see that the join, there's a folder started, and then here showing that the cylindrical being established. Okay, so now I want to do for the others, I want to establish the relation. Basically, this pin with my holder. Okay, this pin with my holder. There are two, one at the top, one at the bottom here. So I will use revolve because revolve is mean that they are rotating on it. Okay, so now I will click on the revolve. And I cannot select the internal, so I will select the part first. And then click apply, let it jump into my reference view. Okay, and then over here I select face and then attach to the reference scope one more time. And then next I will select this holder, not holder, this one is called the core component. Okay, so I also want to select the pin, but now I am not able to select it. very effectively. So I will be going now for the mobile there. Okay, apply. So now it appear there, and I can select that pin. So under mobile scope again, apply one more time. So now that relation established. Now, to establish join, the more complicated your assembly is, the more work actually you need to do. Okay, so that's why in the beginning I did mention, if you want to simulate dynamic, there will be huge work. It will be very complicated. Oh, but of course, the result is very rewarding. Okay, after that you get the result, and then you will be definitely really happy for that. Okay, so now always good after you establish to test them, because sometimes they may be not correctly established. Okay, now you look at it. Okay, you look at it. Hey, I have a new join here. I make a mistake. Yours one may be together with under this folder, but actually doesn't matter. They are in a new folder, or actually they are at the same folder. Okay, so I just leave it. Okay, if yours one is under the same folder, it's okay. So now, on the reward over here, I will configure it to test them. Sometimes they are establish their relation, but the coordination system might be not correctly being defined. If you look at here, my rotation supposedly is on the y-axis, rotate around y-axis. But here the rotation actually is given to me, it is on the x-axis. Do you see that? So the rotation mechanism is not correct. Maybe yours is correct, sometimes it's quite default. Okay, sorry, not default, quite random. So if that is the case, now let's say I want to change. Okay, I want to change. So you need to open, if yours one is correct, then no problem. If yours one is not correct, so then you need to do a work like this. You open that join, and there under the reference here, you need to change. Okay, what you need to change, first thing is you take a look at the detail here. When the time you click the reference, the principal axis. So the principal axis is mentioning is Z. That means just now we are rotating around Z axis. So now I said, no, I want it to rotate around Y axis. So then this one I will change to Y. Okay, but when you change to Y, this actually will change, but you don't bother it. Okay, you don't bother it. Okay, so now let's say you change that, you click back to the reward there. And then now you click on the configuration. Now you can see that now the rotation is changed on the correct axis. Now it's just only the correct axis, but the center point of the rotation also is wrong. Supposedly they are on the pin, right? The center point of the pin. So we also need to redefine the position of this coordination system. But at least this is how, first thing first, we know how to redefine the rotation axis. Okay, so it will be under reference. Look at the principle. Okay, so now knowing that the position, okay, or the center point of the rotation is at somewhere very random, but I want it to switch at the center point over here. So then you will be seeing that here on the detail. Just now we work on the principal axis. Now we look at the origin, geometry selection. So I want to change the position of this geometry. This one, not the global one, the reference one. So here on the geometry, I will going to click, okay, I'm going to click on that circle surface. Okay, anywhere, just click over there. They will be, okay, apply. They will be auto-detect the center point. They will auto-detect the center point. Okay, so now if I go back to that revolve and click the configure, and now it is rotating on the correct manner. Okay, as you can see. Okay, hope that you're following over here. And you have to do it for all the joint. So you must know your assembly very well. If one of the joint you did not do, then you may not getting the so-called the motion correctly. And they are linking. Just now, for the cylindrical, when I'm trying to pull, or I'm trying to rotate, the holder following me because the holder did not have any relation with the other. But now they already have a relation with this pin. So if I configure my cylindrical, especially on the rotation, you will find that, look at behind the part, they're following. Just now it doesn't follow, right? So, and then after that, we move, you can see that they're also following. So from configure, if we are putting all the joint correctly, for our configure, basically we can see before we simulate. Basically, you can see is the movement it is correct. And you must know your design. So now I will do it fast for the remaining 3 joints, the left, right, and the bottom. Okay, I will do it quick. You do yours one, okay? So I don't need to keep explaining that because the work is repetitive. So now I will use that again. Okay, so now I got that and I will configure it. And find that they are also not in the correct manner. So I will click the position first. Okay, I don't want it to rotate on the Z manner and rotate on the Y axis. So now it's done on the bottom. Okay. I will do that for the other. Normally, I will know that their orientation might not correct. So that's why it will be quite common. We are arranging that. Okay, I'm the third one, so I will do it for the last one. So I'm done. Okay. Okay, for revolve, 1, 2, 3, 4, because we have 4 joint, and that one's cylindrical over there. Okay, now we all know that boundary condition. Okay, for assembly, we also need to set their fixed point. Okay, their fixed point. So over here, let's say I would like to do some fixed point that it is basically over here. Okay, later we can try other. So that means I'm just assuming that here this face is attached to another machine, so they are fixed. Okay, I think during the static structural, we also know that we need to fix the position, right? But here, if you look at the transit here, you may not see a fix, and the fix is not allowed. Okay, so we cannot use the static structural that mentality over in the dynamic. So over here, we also use join. Okay, but here we are going to use fix under the body ground. Because my body, this side, I want to fix it. And that fix doesn't relate to any other part. So that's why I use body ground, fix. Okay, so there's the difference between body ground and body to body. Body to body is saying that this part and this part, how they relate. Body to ground is mean that this part, how it relate to another part that is not being seen. Like for example, this face, I want to fix it to on a wall, example only. So that's why I use body ground. I cannot use body to body because he is not fixing with other part that is appearing here. It doesn't appear here. So that's why we use this body ground and use the fix and select that face. And now you can see that I only need to select one. Okay, so now it fixed. And because it's fixed, I don't need to worry about the orientation manner. And there's no configure, actually it is also needed there. You can see there's no configure. Okay, so now on the analysis setting, because they are dynamic, so I would like to set up multiple steps also. One step will not enough for me. So let's say I just create a 3-step over there. Okay, so analysis setting, I just make 3 steps, make it simple, make it fast. Okay, we're trying to simulate rotation. This part, and this part, they are like moving up. Okay, because they can rotate, right? So they can move up this whole thing. Okay, they move up there. Okay, something like this. So this green color one, they move up. So that means I will have something look like that. Okay, and then the position is here. Okay, so now we will make use of that. So in here, I will select the joint loading. Now the joint loading is useful if you set up joint. If you did not set up joint in the connection, this is totally nothing to do with you. Okay, they are interrelated. So now how many joint I have? I'm having 1 cylindrical, 4 okay, revolve, fixed. Okay, don't talk about the fixed now. Okay, fixed is fixed. So now if let's say I insert a joint loading, so they will be showing okay the list that it is according to the joint you created under connection. You can see that. And now which actually you would like to manipulate. I want to manipulate here, or another side also can. Okay. This one or this one, I have 2, right? So I just need to select that. Okay, now I know it's the 3rd one or the 4th one. Okay, no problem. Yours one may be another, but make sure when the time you select from the list, over here they will be showing. Okay, here we'll be showing what it is accordingly. Okay, so that's the list. Okay, so now I'm selecting what actually I want them to do. So on the type, you can see that by having that joint, you can manipulate the rotation degree. Okay, this rotation is talking about the rotation degree. Okay, this one, this rotation it is talking about the degree. This one is a rotation velocity, I think no problem, radian per second. There is acceleration, okay, that moment it is, I mean moment you all know, okay, force times the distance of the fixed distance. Because we have a fixed distance. So they will automatically help us to calculate that, the distance. Okay, but now we try the simple one. I just want it to move. Okay, I just want it to move up here. Okay, so here it is following that. It is anti-clockwise. So now I just check the rotation. Because I already have 3 steps, so I can each step define their degree. Okay, look at the units degree. So I was saying that, okay, in the beginning is 0. And then after that, the first step it is 5. Second step, I want a little bit more, 15. The third step, I want a little bit more, so 30. And the graph can represent that. Okay, so we simulate a simple thing first. So now at the solution here, what result we would like to see? Of course, deformation we want to have. And then the prompting, what we want to prompt. I want to prompt the angular velocity. Okay. So which angular velocity? So over there. So I will think that, okay, this part. Okay, because they are swinging up. I want to know the angular velocity of it. Okay, what else actually you want to prompt? You want to prompt the energy because moving. So I also can prompt the energy. So other than that, you can also take a look at that, but right now I think that will be enough. Okay. So now I try to solve it. Okay, I have my result already. I will take a look at the deformation first. So now you can see that it is moving. You can see it moving faster and faster. The first step, you can see the first step, it is just very slow, and then suddenly they move very fast, and after that even faster. Because just now I putting 5 degree and then 15 and then 30. So every step I increase the degree. So that's why I can see that they moving faster and faster.